Hello, my name is Laura Khan, and along with my colleagues at Indiana University, Orly Esteban and Ravinda Lambadi, we will be talking today about visualizing coffee rust, production, and futures. More than 2 billion cups of coffee are consumed each day, and the livelihood of 120 million people depends on the coffee supply chain. Furthermore, coffee is the second most popular traded commodity, worth over $100 billion annually. Coffee rust is a disease that causes the coffee plant leaves to turn yellow, and it causes more than $500 million in production losses every year. We wanted to study the data visualization in order to understand relationships between these variables. Is there a link between the amount of coffee rust and production and/or the futures prices? Café Arabica data from Brazil, Colombia, and Papua New Guinea was studied in the following years. We have the following hypothesis: that more rain increases coffee rust, that higher temperatures increase coffee rust, that more coffee rust decreases production, and that more coffee production furthermore decreases futures. Some of the existing research that we found were from McGrath, Avellino, and Montage. McGrath describes how temperature and rain affect the amount of rust. Avellino suggests a qualitative link between rust and prices, and Montage uses machine learning to predict future prices. We acquired the data from more than 10 different sources and included the following variables: rainfall, temperature, rust percent, production amount, and future prices, and cleaned and inputted this data into CSV format. We had some challenges in learning the domain quickly enough to find the relevant data. We also had to translate the documents from Portuguese and Spanish into English and combine these data from 10 different sources. Some of the assumptions we made were that the altitudes between the countries were pretty similar, so that's why we used these different countries as a representative sample. Future prices are worldwide and not listed by country, and of course, we're limited by the amount of available data. We began our visualizations by looking at how the data was distributed. We used histograms and kernel density estimates to show the distribution of the attributes rust, production, and futures. Coffee rust peaks between 5 and 20%, as you'll see in the first histogram. In the second production histogram, we see that production peaks at 1,000, and then 3 to 4,000, 1,060 kilogram bags. Futures histograms peaks around 50 and 125 US dollars. Next, we wanted to look at the data relationships a little bit more closely by using scatter plots to visualize the relationship between rust and production and futures variables. We used a log scale, and in the first plot, we saw that rust and production are probably correlated to each other. In the second, we saw that production and futures are probably correlated to each other, but how much? We furthermore did a linear regression visualization showing that rust and production are correlated to each other. Increase in rust means that there will be an increase in production, so we failed to accept our original hypothesis. We also did a linear regression to establish the relationship between production and futures and saw that an increase in production means an increase in futures. Again, we failed to accept our original hypothesis. In order to see how exactly the variables were correlated, we made a correlation matrix. Each variable is represented. Variables that are positively correlated change in the same direction, and if they're negatively correlated, they change in opposite directions. An increase in rain means less rust. An increase in temperature means less rust. An increase in rust equals an increase in production. And finally, an increase in production equals an increase in futures, so we reject all of our original hypothesis. Some of the future work we hope to do is to create a web page to tell the story of coffee rust, production, and futures using D3 and HTML. We also want to use a calendar view, which allows you to see historical prices by hovering over each square. In addition, we want to modify existing Columbia region coffee map so that we can replace similar blue and green colors with more contrasting colors to follow principles of data visualization. Finally, I leave you with a few references that made our project complete and encourage you to contact me at lkhan@indiana.edu if you have any further questions. Thank you.